Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
Here we have a reaction of bleach, potassium hypochlorite, and acid. One of the dangers of using bleach is that if you add some acid to it, you can generate chlorine gas. There's other hazards too, so don't mix bleach with anything else. You get a lot of different types of poisonous gases. This is what the reaction looks like. You mix the acid to the bleach and wow, look at that foaming stuff. It really works. But let's do some stoichiometry with this. Here's the balanced reaction. Nicely done. And of course, this is the chlorine gas that was bubbled away. Now, in this example, you're given a certain amount of chlorine gas that's produced. In this case, 35 millimoles. This is 0.0350, but it's a lot easier to use thousands. Just move that decimal point over 3 places, and you'll be dealing with whole numbers. Now, how do we find out about everything else? That's really all we know here. We've got a balanced reaction, and we've got 35 millimoles of chlorine. Well, again, our ice, initial, change, and end. And we know that if you have two values, you can find a third. And in this case, the only place where we have two values is the chlorine gas that we didn't have to start with, but got 35 at the end. So logically, there must have been 35 millimoles of chlorine gas produced. Now, this change row is golden because once you get one value in it, then all the other values can be calculated based on these coefficients. Here we have a 1 chlorine, 1 potassium chloride, and 1 water. So they both of these have the same coefficient as chlorine, so they're going to have the same change. If you make 35 mLs of chlorine, you're going to have to simultaneously make the same amount of potassium chloride and water. And of course, to make these things, you'd need 1 potassium hypochlorite, which is right there. So 35, 35, 35, 35. This is pretty good. Like I say, one of these and coefficients and you're all set. The only difference is you need twice as much acid. You can't make this chlorine gas with 1 HCl. You need 2 of these, so that's going to be easy enough to double. Now you've got the entire change row made, and you can do subtractions and additions. So in this reaction, the initial amount of hypochlorite that reacted to make this chlorine must have been 35 millimoles. And the acid, again, we ended up with nothing left over, 70 millimoles. And here at the end, our KCl and our water. And all is good. We've found the final amounts of everything that was produced. And we also know how much was used initially. In this case, we also know the concentration of the acid, so you'll be able to find the volume of acid that actually reacted and ultimately find the concentration of the potassium hypochlorite. Well, we'll save that for later.